All right, class. Let's talk about text and font and all things UI. Often overlooked until you absolutely need it, which is probably about where most of you are now or will be soon, is the UI, text and font, how you're going to implement this stuff. Now, the good thing about it, having based on the Game Framework 2D project, is that I've already included everyone installing SDL2 TrueType Font, or TTF. TrueType Font is a standard font style format. There's also OpenType Font, which is like an alternative to that. Basically, it's the exact same thing, but without using proprietary technologies. Because the world of text rendering is more complicated than you ever really think about it. It's one of these things where every game you've played, every application you work on, even this one in front of me now, has text and font being rendered. It's so ubiquitous, you stop thinking about it as a thing until it comes time to do it yourself and then realize it is remarkably complicated. The very idea of having fonts stemmed from the fact that in olden times, fonts or text on the screen was like you'd have like one Unicode character set that would be hard coded into the motherboard of the system you're working on, and that was remarkably limited in those olden days. Today, it's more like having a sprite sheet. Unfortunately, it's not as simple as having a uniform sprite sheet like what we have with the sprite system in GF2D. Fonts are weird. If you just look at text and font here, if you look at this, the E is actually a little bit under the T. These are not uniformly spaced apart. The amount of space between each letter, the amount a letter goes above or below an imaginary line, all of these things, I believe, if I remember correctly, it's called kerning. The style of putting this text into place in the right offset is remarkably complicated. And it's not as simple as just moving X number of characters to the right for every letter and then drawing the new frame of animation. It's similar, but there's rules that come with each and every font. And then how you would render them and blend them and all kinds of font effects. It gets complicated, which is why SDL found it necessary to make a companion library specifically to support fonts. So, let's take a look at it. I actually have it open over here. No, I have it open over here. All right, so this is the SDL wiki for TrueType Font. SDL2 specifically. I know SDL3 is either dropping now or has just dropped. I have not looked at it yet. It is another subsystem of SDL, so it needs to be initialized with TTF in it. And when you have, by the way, always check your return values of your functions so that you know if something has succeeded. When a function returns 0, what does that mean? Does that mean number of errors? So it's cool, which is probably what this means. Is it an error code, which means maybe -1 is the error, or is there, was it true or false? Is 1 good? Is 0 good? It's always good to know what the return values of your functions are to know how to read them and how to check for them. Like with all SDL systems, once you initialize it, you must quit it when we're done. Unlike other SDL subsystems like the image system or the mixer system, there's still more work to be done after you initialize TTF. The idea is that you also then need to load up some fonts. So let's look over here at the code. This is taken from my 3D game library. So some of the stuff is not necessarily going to be one-to-one. And I will warn you, this is over-engineered. The whole point behind Game Framework 2D was that I gave you a minimalistic view to make it easier to understand and learn from, and then add to, as opposed to more mature software, which is as complicated as it needs to be, but isn't necessarily easy to read or understand. So don't look at what I'm about to show you as, oh, I have to do all of that. You do not. But I do want to point out here that when we load the font system, we also need to load the fonts to render with. So any font we would keep track of needs to be, well, kept track of. In fact, I'm going to close this now. I figured probably the best way to approach this is to just start coding it. So I'll make a new file, include my logger, because error messages are our friend. End of line and end of file. Reason OCD. There we are. And now, so we're going to make our own font system. So we're going to make a void font init. And in font init is where we're, let me save this as a C file. Okay, framework.c, font.c. I'm not naming it gf2d underscore because I'm not actually going to be adding this to the library. This is all just my temp code for lecture purposes. And we need to initialize with ttf init. And we need to make sure this actually works. So if ttf init equals -1 or does not equal 0, we can slog the error. Failed to initialize TTF system. And then we're going to return. There's nothing else to do. We're going to, whatever we create, we must destroy. So void font close. And in the font close, we're going to do our TTF quit, which is a void function. It could have been queued up with the @exit, but there's going to be some cleanup we want to make sure we do before we actually call the close. So our font close is going to end with TTF quit. We're going to do our other cleanup first. We are going to need a font file, so we're going to need TTF font. It's probably called load or open font. Open font. Here we are. This is what we need to work with here. So we're going to make a font to work with. What happened there? Oh, I guess I replaced that. I'm going to make my font manager. So my typedef struct font manager. And I'm going to have a font to work with. Now, something I want to point out here, unlike when we're loading in a sound file or a image file, we don't just provide the file name. We also have to provide the point size. So fonts also scale. Most of them are actually built on scalable vector graphics these days, the SVGs internal, so that they can scale to any size. You don't have to worry about artifacting. The SDL will optimize that process by pre-rendering the entire font library when it loads it, which is why you need to tell it how large it is you want it to be when you first load it. So this is one of the reasons why this starts to get complicated. If you want to have more than one font size or style, you might want to have more than one font to work with. One of the, in fact, here's what I'm going to go ahead and do. Let's make a typedef in num. I'm going to call this my font styles. And we're going to go with, by the way, a convention I like is if I have a capital camel-cased enumeration, I prefix all my enumerations with the the capital letters of my type, so that we minimize the risk of reusing an identifier. So I'm going to call this small, font style medium, font style large. Or you maybe want to go with the H1, H2, H6, you know, the style that you can get from what have you, the interwebs. So what I want to do here is actually make a list. So I'm going to do list star fonts, which means I'm going to need some more information loaded here. I'm going to pound include gfc list.h. come out of the list of fonts, which means I actually don't need this just yet. Since this is a list, I'm going to make my font manager a static global font manager equals 0. Now, and then I'll do maybe like font style max. Now, so we start with 0, 1, 2, 3. So we can do like we can iterate while less than max, or if we want to. What I wanted to do now is for I equals 0, while I is less than font style max, I++. And I'm going to make a font pointer. Font. I'm going to set font equals to this. So SDL will manage the internals of the font and just gives us a pointer to it. What file size we want to load? Well, I think I actually provided some fonts. Let me see here. Git Game Framework 2D. I did not provide fonts. I guess I didn't provide fonts. Well, you can always find a font. I'm going to grab a font out of one of my other projects. You can also download them from what I would recommend is free font downloads. So here's another little lesson. Fonts are copyrightable. Fonts are owned. So an artist designs the font and they now own that font and the rights to that font. So if they want to charge for that font, it is within their rights, and it is not legal for you to use that font without their permission. So some people who make the fonts will make a couple samples of their work, and they'll make them freely available. Some people are more of the open mindset and will have Creative Commons licensing on them, but take a look at the font licensing to make sure that you're using something that is legal to work with. And then we can, maybe I could just find some alphabetized font. Blurred. Medieval. Let's look at medieval font. What do we got here? So these are categories. This Enchanted Land looks good. Free for personal use. So, well, I'm only using this for today's lesson, so I can download this. Download started. Did I get it? Cool, I got it. Enchantedland.zip. Let's open her up. And there's the Enchanted Land OTF. I'm going to go to my Git. Game Framework 2D. Make a new folder here. Fonts. And I would always recommend dragging at least the README with it so that you have your appropriate licensing in with whatever project you're working on. Now, it may come a time where like, hey, I finished this game and I now want to release this. You're going to have to make sure you address all the rights associated with all the media that you're using that you did not create yourself. So fonts. Maybe you need to reach out to the original artist and see if you get permission or give them some cash so that they'll let you do it. Or at the very least, if they say, yeah, go right ahead, but give credit, you need to include the credit for that font either in the credits to your game, if you have a screen for that, or in at least a text file that gets distributed with your game. Same thing applies to any audio that you may download. So you can find open sounds and free sound effects, and there's just like that. There are going to be licensing issues to be concerned with. Always keep the README or the license stuff associated with it while you're building it. Don't think you're going to be able to go back after the fact, after you may have even modified and cut up some sound effects, and track down all the original artists that you are ending up ripping off. So, you know, do the right thing and just attribute stuff accordingly. I'm going to make this actually just easier to make that an underscore. Copy, rename. Just to make my life a little bit simpler. All right, so now what I want to do is I'm going to open up fonts/enchantedland.otf, and now point size. I'm going to start this one off at 10 plus I times 2. And this will basically mean is the first one will be 10, then 12, then 14 as my font styles. In fact, maybe we'll make it times 4. So it'll be 10, 14, and 18 as my font sizes. Oh, no, I'll forget. I need to have the I. If not font, I'm going to slog the error. Fail to open font. I mean, if this was a variable, this would be better. And then we're going to continue. Otherwise, what we're going to do is we're going to GFC list append, appending to the list, font manager, dot fonts. And we're going to add the font to that there. I do need to, before I actually even do this, is I actually need to new the list. So my list, my fonts, my font manager, dot fonts equals GFC list new. And I should error check that, but for now I'm not going to. Error check here. Just in the off chance something is horribly wrong. And then we queue up the add exit. And we're going to call our font close on exit. And then now we're going to clean up what we have done here. So int I comma c, c equals GFC list get count. And I want this to be my count. For I equals 0, while I is less than c, I plus plus, probably my most written line of code ever. And now what we have opened, we must close. So where is my closing? Oh, cool. To dispose of it. So this is the cleanup for that. And we're going to give it, well, I actually need a font here, don't I? Okay, because remember, the list has no type association. So I need to capture font equals GFC list get nth, and I want to get it out of this list, and I didn't use n, I used I. All right, if not font, continue, skip the list. This should not happen, but this is our sanity check to make sure that the list didn't get corrupt somehow. And then we're going to close the font, and then we are going to GFC list delete the font manager, and then I'm going to mem set font manager to 0. That actually gives me the address of font manager 0, the size of my font manager. How do I know what the parameters are for this function? I've written it a billion times. You can always just look it up. So I've cleaned up and I've zeroed. Now I've quit the whole system. Created a new font. All right, cool. Now, that's just our basic setup for things. Let's now talk about what we need to do in order to render text. And for that, let's go back to here. And we're going to look at all the TTF renders. So there's render glyph, which means a single letter. There's render text, and then there's different ways we can render the text. And it looks like there's even more ways since the last time I even looked at this. So render text shaded, solid, Unicode, UTF-8. Actually, I like using UTF-8 because you can add in a bunch of other features. Most of them you will see have a solid and shaded and blended. So I've got UTF-8 blended. Oh my God, they added text wrapping. So this last one, text wrapped. They did not used to support text wrapping as a thing. And I had to write my own system. And my own system is kind of buggy. And I'm looking at this, I'm excited to go back and rewrite my code to use blended wrapped, because I cannot tell you how much of a pain in the butt it is to figure out how to wrap text. What I would basically do is I would take my big string of things, pull out one word at a time and add it to a new string, ask TTF-8, so there is a Size text. Calculate dimensions of a rendered string of text given a font. So if I have the font, it will write into the width and height given a text of what something is. So that the process was grab a word, get the text width from that. If it's greater than, or if it's less than my width of what my desired width for my bounds are, add another word. And then try again and see what that width is going to be. And then try it again and see what that width is going to be. And eventually it's going to exceed my width. And then what I need to do is then render that line and then move down to a new line. It is a complicated process. But now it looks like, finally, I don't know when it was added. I have to, maybe someone wants to look it up for me. I'm not going to do that now. We have the ability of text wrapping. And now we can set our wrap length. Now, it still might be useful to do the size text. I guess they don't allow wrapping for your... oh, you almost certainly want size UTF-8. It'll give them width and height of this. Yeah, Unicode UTF-8. Set wrapped alignment. Oh my God, there's so many new features now. This is exciting. Font height. Oh, the font height of the pixels, I suppose. Anyway, I'm getting excited and off track. What I want to now do, just simply, is look at the different ways we can render UTF-8. So we have blended, LCD. I'm not actually sure what this one's for. Render the text at a LCD subpixel quality to a new surface. Neat. This might even be fancier. I'm going to avoid the new fancy one just in case it's not supported on all systems just yet. Generally what you want to look at is solid, shaded, and blended. Solid just has your foreground color, and the background color will be some, will either be alpha or a color key. So I don't think I remember talking about color keys in a previous discussion, but just to tell you what that is now, there are different ways we can handle transparency added as an image. In the before times, before we had 32-bit color or 24-bit color, we would have just a set color that was going to be the clear color. So if the color happened to be color 0, then don't draw that pixel. That's how transparency was handled for a very, very long time until we added alpha blending. Shaded provides a little bit more features. So it will have a foreground color and a background color, and it'll like blend and feather the edges, and it'll look nice. The other one is blended, which I think is the one I use myself for things. So you have a foreground color and it blends to an alpha channel. Yep, that's what that does. This will not word wrap the string. You'll get a surface with a single line of text as the string is required. I can use wrapped instead if I want it to be limited to a certain width. Let me see what the wrap does. Maybe I can give a wrap length that says an unsigned 32-bit integer. Text is wrapped. If a wrap length is 0, this function will only wrap on new line characters. That is so useful. Yes, I'm going to do that. Let's test this one. Let's make sure we can now render the text. So we're going to make the void font draw text. And we're going to take a constant char star text as our parameter here. Give myself some more room. And we want to draw. We need to work with this. So the font, we're going to need to figure out what font we're going to do. We can either take the font as a specific font pointer, or I'm going to take it as a font style. So since I define this as a type, I'm going to take this as a font style. In fact, because this is now going to be a global thing, let's start working on our header file as well. my boilerplate needful. And this is probably going to need to include, at the very least, my GFC text.h. I'll probably be doing some stuff with that. And include, and this is going to be font.h. Neat. All right. And yeah, I want this not in here. I want this there. While we're at it, we can also start making this more robust. Init the font system. Auto closes on exit. Cool. By the way, you probably want to add a parameter here to take the font sizes you want, or drive it off of config. So I have my own system I will set the name of a font, what I will refer to it as a string. So I can say like H1, H2, small, medium, large, title, whatever I want to call it, and its point size. So I can have mix and match different fonts and sizes as I need to, and then I can refer to that in code based on what I have loaded. Back down here. And then we're style here. All right, so we're going to need the TTF font. And we're going to set font equals this one. I didn't need both, except instead of I here, it's style. Oop. Now, if not font, slog an error, we're going to return failed to render text %s, maybe put that inside quotes, missing font style %i. So we failed to do the text with this style, and then we return. All right, so this function is going to return a surface. I call it surface. I'm going to set surface equal to this. The font we're going to use is the font we have loaded. The text we're going to render is the text that we asked for. The foreground color. Oh, maybe we could take a color as well. Color. All right, so I've got a color system that I've been using with GFC, which means I'm going to want to include that color.h. I apologize if you can hear my kids in the background. They have off from school this week. GFC color. One decided to start playing Elden Ring. The other I'm trying to get to play Helldivers. And let's see. One of these is a convert to, that's config. I want color. One of these will produce an SDL color, I believe. Here it is. All right, because I don't know how SDL works with their color system, but I have my abstract color. So what I'm going to do is the color, SDL color, FG, and I'm going to set FG equal to this. Cool. Not the type. All right. So now the foreground color and wrap length, I'm going to set it to 0, so it'll only new line with a new line character, which I like the idea of. Maybe I can make the same function. It also does wrapped specifically, or just a line. You can see that it is not a simple thing for that. Now, we have a surface. There's a problem with that, is that SDL surfaces are in CPU memory. We need an SDL texture in GPU memory. I do remember that I did make a wrapper function to handle that conversion. Somewhere here. Create surface, split surface to screen. thought I made a system to do this. I didn't. That's terrible of me. Oh well, we'll do it anyway. Oh, but we do need to also make sure that we convert it, because there are different pixel formats that we use, and my system has initialized to 1. There's no guarantee that TTF has rendered it to that one. If I remember specifically, it was ARGB, but my system, I think, is RGBA, so we need to absolutely convert the surface. If you fail to do this next step, well, fun stuff can happen. So I'm going to do this copy here. So graphics screen convert. And the way I design this is that it will return a pointer to a surface. And it takes a pointer to a surface. So I don't want to give it surface. I want to give it the pointer to my surface. So it's a pointer to a pointer. Because C is passed by value only, I'm only getting a copy of the memory address. I'm not getting where this pointer is. I'm getting the memory address that this pointer points to with this pointer. But a pointer to that means I can change what this is pointing to. So what this will do is this will convert and delete the old pointer and make sure that my pointer is now set to 0 so that I don't accidentally try to use it. However, I'm just going to immediately reassign it anyway, so that shouldn't matter. And at this point, any of these surfaces are null. We would want to error check on this. So if not surface, we would slog the error, return, and we do the same thing after that process. And now if we take a look at my SDL sprite system, we have to do the same thing for SDL sprite. Create texture from surface, given the renderer and the surface. So we are going to do the same thing now with the texture. Which means I'm going to need an SDL texture. So SDL texture star texture. So texture equals create texture from surface. It's going to get the graphics renderer, which means I'm going to need a pointer to my GF 2D graphics.h, and then the surface that we're going to convert. If not texture, slog this error, return. Probably going to need to free up SDL surface. What's the name of the function that clears it up? It should be in here. SDL free surface, that's the one. SDL free surface, surface, and then clean out that up. All right, we're almost done, almost done. We now need to actually then draw the dang thing. So let's go to, where's SDL draw? Not SDL, yeah. Draw to surface, no. Draw image, draw, render. All right, so we want to call, we have a lot of stuff to do, don't we? Yes, we do. Although those should be done. So by the way, color mod is a modulus operator on the colors. And by what that means, if you think about it, the modulus operator in math, you get referred to. If you look up the definition, it says provides the remainder of a division. Cool thing about a remainder is that it's either always 0 or 1 minus the number in integer space. So you will have whatever the number you're modulating by, you will keep it under that number. So if I were to modulus a color that's normally in range from 0 to 255, and I give it a modulus value of 128, I will make sure it does not go over 128. It will, cap the color, so to speak. Same thing with the alpha mod. So they're separate operations for the alpha and then the 3 colors. That's what the color mod and the texture mod do. It's a way to filter color out. It does not add to, but it can limit can be useful for things like color shifting. In fact, I use that in the I use that here. Another little aside. So the color of the mouse here, that purple does not come from the sprite. The sprite is actually rendered in a very bright grayscale. And because of that, I can then shift it to any other color, because white is the addition of all the colors together. But then I can then filter it out to other colors. This is just basically filtering out everything except the purple. But I'm actually going to leave that one alone. Now I'm going to call render copy. I'm actually going to find that over in the SDL, render copy EX. I think I can get away with just a simple version of render copy. Yeah, I don't need all those features for just text. All right, so now I have a texture. I need the texture. I need the renderer. So here's the renderer. The graphics system has the renderer, and it provides it with this getter. The texture we're going to render is that texture. The source rect is going to be null, meaning the entire surface. And now I need to figure out where the hell I'm drawing this to. So I need a vector 2D for position to draw this to, which is why I didn't make this in the header file yet, because I needed to discover what we needed along the way. So I need an SDL rect. The destination rect structure, or null if the entire rendering target. Texture will be stretched to fill the given rectangle. So I'm going to need to do some work here to figure out the width and height of my texture. So that's going to be position. Now I need rect. Okay, so my rect.x, so an SDL rect, by the way. Where is the SDL rect? X, Y, width, and height in integer space. So x equals position.x, y equals position y, rect dot width equals. Maybe I can't like provide a 0 and just have it do the whole damn thing. Yeah. Guess not. All right, so I'm going to need to give it the surface width, and height is going to be surface height. And now this takes a pointer to a rect, the address of the rect that we've created here. All right. Now, once we have rendered the text, we no longer need the surface or the texture alive anymore. So we're going to free that surface and delete that texture. So where is the free surface? And texture. Oh, they're already calling this legacy. Create, destroy texture. Shame they couldn't have a consistent naming convention. It's surface, free surface, and then destroy texture. All right, now that we know what this is going to look like, let's copy in the header file. Let's put that there. Give ourselves what we're going to do. Add brief, render text to the screen. At parameter text, what to render. At parameter style, what style of font to render with. At param color, the color of the text. At param position, where on the screen to draw to. All right, now let's test it. Let's go to game .c. And we're going to include, actually at this point, it'll probably be one of our more stable libraries. Pound include font.h. And every frame, before I draw the mouse, after I draw the world, let us draw some text to the screen. The text we're going to draw is going to be press escape to quit. \n isn't that neat. Font style is going to be small. Color, I have some GFC color functions too. Actually, I even have some prefabs. So I'm just going to say color cyan. And the position I'm going to render it at is we vector 2D. And I want it to say be at 1010. Semicolon. Let's see if this code works. Oh, there's typos. Unknown type name to type font. Oh, of course. I forgot one of the most cardinal things, which is to include. Again, the most stable first is not going to be my code. It's going to be the included library. And what is the name of that? Doop-a-doop-a-doo. Sprite included. SDL image.h. So this is going to be SDL TTF.h, I think. Let's find out. No, not that one. Oh, and it would be here. No. Do I actually have yes, I absolutely would have that installed. What would that be? Where would I look that up? User local include. No. User include cd space SDL. It is SDL underscore TTF.h. What's wrong? TTF.h. Git game framework source make. Oh, okay. I guess it didn't like the brackets. FS max undeclared. Oh, I never actually even included my own font.h. Cool. Slog, missing terminator. Oh, man. What line was that? Line 76. Oh, yeah, there we are. Oh. Undefined reference to close font. Ah, yes. So I already had everyone who followed the Windows tutorial set up. You already would have included the TrueType font stuff. The Linux people, pay attention here, because we're going to have to do a little bit of work on a makefile. I forgot to include in the base project, because the base project doesn't actually use any font stuff, I need to add -L SDL2 TTF. So we need to add the flag that we're going to link against TTF. And if you're going to do any sound, -L SDL2 mixer. While we're at it. That's MIXER, not to be confused with our lab name. Boom. Let's see what happens. Oh, cool. We have an error to deal with. Failed to render text. Isn't that neat? Missing font style 0. Cool. Let's go to the beginning of this error block. Failed to render text. Okay, so we didn't get any other errors. Missing font style 0. Let's take a look. Oh, you know what we never did? We never actually initialized the system. All right, so I'm going to put this after my sprite system, but before entity stuff. Make. Wow, that is very, very freaking tiny, but it's there. All right, so we're going to have to make that much, much larger. So this is why it's probably better to drive this from config as well. Wow, that's even still extremely tiny. And by the way, it will be different per font. Every font kind of has its own point size and what that means. But yeah, that's awesome. There's text on the screen. All right, so those of you who are paying attention might go, wait a minute. Can you go back and look at that render function? Sure. The render function that we're calling every single frame as we're calling draw text. Yeah, let's take a closer look at that font system. So whenever we're drawing this text, text. So why didn't someone speak up? You know, let me write this whole code base with a typo in it. Draw text, not test. So the process of drawing this every frame is we are rendering a surface, converting that surface to screen surface format, creating a texture from that surface, rendering that texture, and then deleting the surface and the texture. That is remarkably wasteful, especially when you consider that most text in a video game is going to be on frame for more than one frame, on screen for more than one frame. Oftentimes just always there as part of the system. So this is where efficiency is going to come into play. What you would want to do is cache the images that we have made. So what I want to do here is go up here and I'm going to type, let me make another list. Recents. And whenever, what I want to do is make a new function. Well, first of all, when I initialize the whole system, my recents is also going to be a list. And now I'm going to make a function void font get recent. Except we're not going to be a void. We're going to return an SDL texture. No, we're going to get more than that. We're going to make a whole new type. Type def struct. Oh boy. Oh boy, it's getting complicated. So type def struct font cache. And in here, we're going to have an SDL texture, the texture. We're going to have an SDL rect. No, we're just going to have a vector 2D. Actually, now the size would probably be built into the texture. Let me look back again at SDL texture. Here. It doesn't have any information that's exposed here. All right, so we're going to have to cache that. Vector 2D size. And text line. Text. Actually, no, I'm going to make this a text block. The reason I'm using a text block is that it's a lot of text. If you are doing more letters than this, then it's probably worth it in your best interest to allocate the entire dang thing. Actually, maybe we should do that instead. We're already allocating information. Let's do a whole damn thing. So we're going to do a char star, the text. Oh boy, we're getting complicated now. So font recent is going to give us a font cache. We need to get constant char star text. I need the font styles style, which means I'm also going to need to have this matched in here as well. Yeah, we'll call it style. Keep it consistent. Color. Oh boy. Position. We'll actually leave that one. We'll leave that one. That doesn't need to be in the exact same position every time. All right, so if not text, return null. We can't possibly have returned something there. And we're going to do a linear search through our cache. For I equals 0, while I is less than C, I plus plus. If we go for the whole thing, return null, it's not found. And then cache equals GFC list get nth of this guy, comma I, C equals GFC list get count of this guy. If not cache, continue, kind of controller continue. And now we're going to check to see if GFC string L compare of my text and the cache text. If this does not equal 0, continue. We're going to skip this. That's a reason to not match. If the cache style does not equal the style, continue. And then if the cache color, oh, here I need to do a color comparison. Do I have a color comparison function? I think I do. Yes, check if two colors are the same color. Heh. 1 if the same color, 0 if not. Remember, always check your return types to make sure you're asking the correct question. If color comparison between color A and cache color B, if they're not the same color, continue. So if we've managed to match all that, we're going to then return cache as the one that we have successfully found. By the way, probably also want a timestamp. uint32 timestamp. Neat. That's get recent. Now let's make one. Void font add recent. And we're going to take the same information. So we're also going to add the texture as well. Oh, size. Make sure size was another thing we needed to make sure that we match on. If cache size does not equal size, continue. All right. Now what we need is a font cache pointer. Cache, let's do some sanity checking. If not
text or not texture. Return nothing to do. We should err on that, but this video's already gotten very long. Cache equals GFC allocate array, size of this type. I want one of them. If not, cache. Return. Again, error, then return. And now let's populate what goes into the cache. So cache texture equals texture. Cache size. Oh, size was point size, wasn't it? And we have the size of the image that we'll need to have brought in there. Oh no, font style has that built in. All right, so I didn't actually need to match on size. I lied. This, however, I do need to have, so it's a vector 2D size. This doesn't yet need to be matched. Vector 2D copy. If I remember correctly, it is source equals destination. Destination equals source. Okay. So destination is going to be cache size cache style equals style. And now I need size type length equals string len of the text. Always add the 1. And now we're going to do cache text equals GFC allocate array, size of char, and I want length of them. There, now I've got a length of characters. And now I can do a string copy. Is there a string n copy? I guarantee there's a string n copy, but I doubt Windows supports it. Yeah, it's a standard function in string.h. Makes sense. Destination, source, size. Just make sure that if it's an improperly formatted string, it's not going to copy past a 0 if there was a missing null terminating character. So try this string and copy. If on Windows this doesn't work, then oh well. But I'm going to copy into the cache the text for the entire length. All right. Now we are going to GFC list append. The list that we're going to be appending to is the recents list. And we're going to add this new member of the cache to it. Oh, but before we're done, we are going to cache timestamp equals SDL get ticks. This returns the number of milliseconds that have passed since the program has begun as an unsigned 32-bit integer, which is what we did with timestamp to make sure that we keep track of that. Okay, now all that. We're going to, at the start of this, before we even start rendering the font, before we do anything, what I want to do is font get recent. We are going to have a cache here. cache equals get recent based on our text and our style and our color. If cache, we're actually going to return. But what we're going to do instead is, we're actually going to do this line again. We're going to set the timestamp equal to now. We're going to update the timestamp. We're going to keep this fresh. SDL get ticks, cache. And now what we're going to do is we're just going to render the texture. We're going to do this bit right here based on our preloaded whatnot. So our rectx position that we're setting here, our surface width and height that's not what we're defining it as anymore. It's going to be the cache size dot width. Oh, did I make sure I set the size? I make sure I need to set the size. I did. I copied it. Okay. Size width, size height. All right, so now this we're using the cached version of the texture. This is the cache texture, and we're using this rect again. All right, now we're that's all we're doing. Like, hey, we already have this. Let's grab the one we have and draw that one and end. If not cache, so if we failed to find the cache, we're going to go through all this process. We're going to what we're going to not do is we're not going to destroy the texture just yet. Comment that out because we'll need it later. Now what we're going to do is we're going to add to the cache. Okay, so our size here is going to be vector 2D from rect.width and rect.height. The texture is the texture that we just rendered. The color is the color that we used. The style is the style that we were provided. And the text is the text that we have done. And now we've added that to it. And we're not destroying the texture. Remember, this is just keeping track of the same texture we just created, so we don't want to destroy it here. Now we need to do a cleanup. Void font cleanup int IC and cache and uint 32 now. Okay, so now equals SDL get ticks. C equals, where's our linear search through our, I'm just going to copy all this. Here's our linear search boilerplate code. Cool. If not, it's cache continue. Now, what we're going to do is check the timestamp between now and then. So if cache timestamp is whatever we're going to say our threshold is, say 1,000 is less, no, is greater than, no, is less than now minus 1,000, no, greater than now minus 1,000. No, I can't brain right now. If now is greater than the timestamp plus 1,000. That's the, now I can brain. So 1,000 ticks since the last note was used. If we have exceeded that, then what we're going to do is delete that from our array here. So let me void font cache cleanup cache free, and we're going to take a font cache pointer. If not, cache return. Now everything that we've created we must free. So the cache text needs to be freed. Since we allocated it, we free it. The texture that we created, we're now going to destroy. And just to make sure, if just sanity check, because free will crash if we give it like a null pointer. So free. So if cache text, I can't imagine that happening, but making sure. And then same thing here. If texture, delete the texture. Was there anything else in our cache type that was allocated? No, other than it itself. And then we're going to free the whole damn thing, like so. All right. Now we're going to call this. Like so. Free the cache. Problem is, what's going on, so just a little bit of how the list type works, since it's an array. And so I've got all these things that are going on, and at some point I find this one needs to be deleted. So what I'll end up doing is delete this. So however many I've got here, let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm at 8 here, and that's the one I don't want anymore, and I delete that. But my counting variable is while it's less than C, and I deleted 8, only now this one is 8. So what I actually want to do is iterate backwards through my array. I'm going to start with 10 and go backwards to this, so that if I delete something, I haven't changed the order of the stuff that I haven't gotten to yet. So what I'm going to do is set I equal to C minus 1, while I is greater than or equal to 0, I minus minus. So now I'm just going to iterate backwards through my array to make sure I don't have any weird artifacts from deleting stuff and then changing the order of stuff that I still have to do with. Sometimes you do want to iterate backwards through things. And we're going to delete that. Now that I've deleted that out of the array, I also need to delete that point in the array. So let me go to my list, and I want to delete nth. Something along those. Delete nth. Delete the element at the nth position in the array. This does not clean up the information that this list is referring to. Cool. And the list we're freeing from is this one. Proper list management. All right. Now, one more thing I want to deal with is when I font close, I actually do want to delete the whole damn thing again. Wait a minute. Yeah, okay, yeah. I want to do this also for my recents. So I'm going to iterate through my recents. Oh, damn it, I did it. I'm going to need a font cache pointer. And we're not going to close the font. We are going to free the cache. And then we're going to delete the recents list. Okay, that was a lot to code before I typed. I'm sure there's typos. Let's find out together. Font cache free. Implicit, oh, right. I need to forward declare that. Yes, okay, font.cli 161. .x, .y. Yep, cool, make. All right, now what I want to do is make sure I call, so the cleanup, I want to put this in my header file. It's like garbage collection. Oh man, we've just implemented garbage collection in C. Take that, Java. And I'll do that as like once a game loop. Make. There's my text, and in theory I should not be allocating it any more than I need to, and we can test that. I can give myself a little bit of trace. In my draw here. So this is where I'm drawing from cache. So slog drawing text from cache, drawing text fresh. Oh no, it's not working. All right, it's not working. Neat. Get recent. Why is that not working? Let's go to this function to make sure we're doing this correctly. All right, so get the nth. Go through it. If not cache, skip. All right, so string L compare will return 0 if it's the same. So if it's not 0, skip. If the styles aren't the same, skip. If the colors aren't the same, skip. Wait, did I set color when I added? Add recent. I didn't add color. And let's go to color copy. No, not color copy. Hold on. Okay, there we are. Or color copy into the cache color. Drawing from cache. All right. Let me turn off that trace now. Always test. All right, 1,000 might be too small, might be too large, depending on what you're doing. Maybe you want to keep it alive the entire time the game runs, because if you've rendered it once, I'm going to render it again. Maybe not clean it up until we explicitly want to clean it up between levels or something. It's up to you, but you've got the blueprints now from this. Also, in my experience with SDL, it renders stuff so fast that unless your game is extremely text heavy, you can probably get away with a simple version of it without optimizing it with a cache going forward. But hey, now you know how to make a most recently used cache. I think is what that one's called. Correct me in the Discord. And I'm ending this video here. Thanks for watching.